All right. Well, it looks like we have some people coming in here. If you're logged on, you are at the Retrotec Frequently Asked Questions webinar. We figured this would be a good way to wrap up our webinars for the year just by presenting some of the most commonly asked questions that we get for our tech support team. So we've got a good list that we're going to go through, some that we've compiled from our collection, and then we actually had some folks email some in too that we're going to include as well. So some will cover some very basics of air tightness testing, and we'll get into the weeds of some software things as well. So we appreciate you all joining us here. My name is Sam Myers. I serve as our in-house building science consultant, and on here with me, we also have Lee Candigalli, who heads up our tech support team, along with Tim Fisher and Noah Lawrence. So the full tech support team is here. So if we get any tech support emails or calls over the next hour, they'll have to wait because we're all here and present, of course, unless you're here. So this is a great opportunity to ask questions too. Please use the I believe it's the Q&A window that usually works well for us. If you have some questions along the way, or if you brought some to this webinar, maybe it's something that we didn't initially cover, we're going to stop about halfway through, so feel free to pop some in, and we'll get to you there, and we'll also stop again at the end and see what we have left over. So wide range of topics today. So we'll go ahead and kick it off with the first question. Tim, I believe you're going to start us off with some calibration questions. Tim, can you hear us okay?
Yeah. Can you hear me fine?
Great. Yeah. Thanks for coming on today. So when I need to send my equipment in for calibration, or when do I need to send my calibration or my equipment in for calibration? What's our window like for that?
Well, generally for energy, we try to send all gauges and all fans in every 5 years. There are different standards that require different calibrations for like fire prevention, and usually most of those, like NFPA, is sending in your gauge annually, and then your fan every 5 years. The easiest way to do that is to go to retrotec.com and click on the calibration tab. I think you can grab it there. Yep, right there on the very top next to the logo. And you click on that, and then you fill out this repairs and calibration service request form. From there, I'll send you an RMA, which is basically like a pack list that lists all the items to send for calibration. Couple of things there. If you have a 3,000 or a 6,000 fan, you do not need to send your drive unless you're having issues with your drive. So that should save on shipping as well.
So Tim, you mentioned for energy, I think it's good to kind of explain to people what that means. So that's a term that we use kind of internally at Retrotec. We use energy and fire. So there's really two totally separate industries that we serve. So when we say energy, that means if you're using a blower door to perform an energy audit or just an air tightness assessment on a whole building, where you would use just our standard fan testing software or our cloud if you're going to go the software route. Basically any residential structure where you're just trying to maybe do a comfort consult or energy audit there. Fire is where you'll hear the term enclosure integrity, where we actually use blower doors to evaluate a room or a space to see how well it will work with clean agent fire suppression systems. So two totally separate industries that we serve, and they have some different needs for calibration depending on what standards they're being tested. So yeah, thanks, Tim.
Mm-hmm.
Next on the list is, how do I get a copy of my current calibration certificate? This is one we get quite often.
Yeah, and the easiest way is to take your device and point it at the QR code, either on the back of the gauge or the back of on the top of the fans that you're working with. And then that will take you to a portal.retrotec.com where you can download your calibration certificate from there. This will only work for fans calibrated after 2018, I believe. If you have any older equipment that you need to know about, you can just send us a line at support@retrotec.com. It's at the bottom of the screen there. And then if you send us those serial numbers, we can look up in our archives and see if we can find the last time the equipment was calibrated.
Yeah, so these QR codes are something that's, I guess it's fairly new. We've been doing it just for a few years now. But I think it's something that a lot of folks probably just haven't noticed. So a handy way to be able to pull that up. And we also have a new way to do it on the 32X that we've done.
Yeah, you can find it directly on the gauge.
Yeah, so if you pull up the gauge app, you see it circled there right in the middle at the top, and you can pull up your certificate for the gauge. So new feature on the new gauge there. Cool. So Tim, while we still have you here, we've got another question is, how do I check if my Fantastic software has been updated?
Okay. Let's see. I should open that up really quick. Is it coming through?
Yeah, there it is. You can see in the page there.
So for Fantastic, on the top corner up here, you would go to File, and then scroll down to where it says Check for Updates right here. Now, mine is the most recent version for this. This was a Dev Fantastic, but it would work the same on the public version. And if you did have an update, it would tell you on this screen right here to close out the program and then reopen it, and then it will begin the auto update of your software. Now, for integrity, let's see if I can get that opened. It should do it automatically. As soon as you open it up, it would check for an update and then automatically give you an update. But you can also check it yourself by going to File the same way and down to Check for Updates. And it will let you know if there's an update available. So pretty straightforward.
And of course, I guess for this to work, you'll need to have an internet connection to kind of ping back and check.
Yes, correct.
Yeah. All right. So here's another one. How do I get my company listed on your Retrotec Find a Tester webpage? So, Tim, this one has your name on it still.
Okay.
You just want to do a quick explanation of what that feature is and then how to get on there?
Sure. Let me grab another screen over here. Okay. If you go to the top, let's start at the Retrotec main page there. And again, at the very top, you'll find a Finder Tester section. And you click on that. And then if you look right here, underneath where it says Commercial Tester, you can click the Add a Tester, and then there's a request form to send to us, and then we can get you listed that way. Now, if you've done any training, you might be listed automatically after the training completes. But that usually takes about, I would say, a week and a half after the training. Is that about right, Lee?
Yep, that's correct.
Okay. Otherwise, you could go to the site, click Find a Tester, and then click that Add a Tester button right here.
Yeah, and we tried to break it up into different categories because we know folks use blower doors and duct testers for all sorts of reasons. So there's fire testers, large building testers, residential blower door, residential duct tester, and commercial duct tester. So usually it's a different type of company that's going to do the testing on that specific kind of equipment. And there's also a handy little map that's there too that starts zoomed out. And anyone that is requested to be a part of this, have their company listed on here, you can kind of zoom in to your area and see if there's a tester nearby. If you're a homeowner that has stumbled across this looking for somebody to help them out or another company. So that's just kind of how we envision this to work. So if you're not on there and you want to be, go ahead and head to our website there and send the form in, and then we'll get you at it. All right, Lee, we have you up next. This is one that I get a lot. I know you guys get it too. We ventured this question quite a bit, and that's, what is a good result versus a bad result, and how do I tell?
Yeah, that's a great question. And I think it has two parts. So there's the like pass fail requirements that you'd want to hit. Like, for example, if you're doing a duct test, maybe you need to see 4 CFM per 100 square feet, and you can't have anything over that. So a bad result in that sense might be like 5 CFM per 100 or anything beyond failing. Um, and there's different results required depending on the test you're doing and your county or the code that you're testing to. So that can be hard to answer with kind of a one size fits all answer. So there's the pass fail requirements, and then you also have the quality of the data that you're recording. So you could take a blower door or duct tester point, and that data you record might not be a good point. It might be either inaccurate or have some kind of issue. General recommendations here are make sure that your envelope or your duct is set up as it should be. So if you're doing a duct test, make sure all your registers are sealed. And nothing's going to pop off while you're testing. If you're doing a blower door test, make sure all your windows and doors are shut, all the interior doors are open. Just have your preparation set and make sure that nothing's going to change while you're recording. And then for taking an actual point, you want to make sure you're using the smallest range that lets you get to your target pressure, kind of a general recommendation that'll ensure you get a good result. So pick a range that the fan has to work fairly hard to get to your target, and that will ensure that your fan pressure is high enough. So the way that the fans work is they take a pressure differential across the range plate. If you're familiar with our fans, they have like a B8 plate, for example, on the blower door. Yeah, Sam, if you have yeah, perfect. So there's that ring or plate that you put on the intake of the fan, and your gauge is measuring both the house or room or duct pressure as well as the pressure across the orifice plate. So if that pressure across the plate's too low, it's not going to be able to calculate a flow result. And if it's kind of right on the border of just enough, you might get inaccurate results, or it might cut out and show double dashes instead of a flow result. So there's kind of a few elements to making sure you have a good result. Just you want to ensure your data you record is quality data, as well as having that result be within your allowed parameters. The other thing I wanted to mention is there's a time averaging feature on the gauge, and this is a really common mistake, is when you're doing recording or when you're taking a point, you should be waiting at least 2 times that average after the pressure settles. And what will often happen is people will have it set to 30 seconds by accident, or 10 in this case. So you run your fan, you see that channel A hits your target, you go and you take a reading, but you haven't waited 2 times that interval. So that pressure might actually change as you're reading or as time progresses. Generally, just want to keep that averaging interval low unless you need to cancel out wind or that kind of thing. If you're getting a lot of fluctuations, you might want to try bumping that parameter up. But I think that's kind of the general. Good point, Lee. Yeah,
the time averaging feature. Yeah, I was just going to say the time averaging feature. One that you mentioned wind, and that's one thing that really helps with. If you really want to get a good baseline of what's happening outside versus inside on a windy day, we'll get to that later, but that's usually where you'll go for that. But yeah.
I think that was the main points I wanted to talk about for this question. Okay. Am I missing anything?
One thing that I was going to add is, there might be some cases where someone's doing a blower door test or a duct leakage test on a house that may not have a code. For example, I'm here in North Carolina, we don't have an air tightness code for envelopes or ducts, but yet we still see folks doing it for quality control. And those scenarios is where I usually get this question the most. It's like, how do I know if it's good? I have nothing to refer to. And so there's some different ways that some folks like to do that. For blower door tests. Some people just like to look at the air changes per hour number. And if we look at most other codes across the country, lots of times that'll range from 3 to 5, usually, or maybe even 6. I know Florida goes up to 7, but if it's lower than 3, that's when they make you add mechanical ventilation. But usually we'll kind of see it around 4 or 5 for states that do require it. But we also have some folks that don't like air changes per hour. And there's good reason for that, because that metric doesn't put houses of different sizes on an even playing field. It's harder for smaller houses to meet a certain target. So if you're looking for 3 air changes per hour at 50 pascals, it's going to be a lot easier for a larger house to pass that than a smaller house. In that case, what some people do, they just look at the floor area, square footage. Let's say we have 1,000 square feet. If it's 1,000 square feet and it's getting 1,000 CFM, then they'll say, okay, that's about average. We have a lot of HVAC contractors that are using that method. It's quick and easy, but it's not really accurate all the time, especially when we get into larger houses. If we have a 4,000 square foot house and they're moving 4,000 CFM at 50 pascals, that's a lot of air leakage still, even though it is a big house. I mean, that can still leave a big window open, pun intended, for lots of problems to happen as far as comfort and humidity goes. So the best way to look at air leakage as far as a specific house or building goes is by looking at the envelope area. And it requires some more work. If you have plans, that's the best route to go, because then you can go and take those measurements off the plans to calculate that envelope area, the floor area, all the walls and the ceiling all added together. And then look at the CFM per square foot of envelope area, 50 pascals for residential, 75 for commercial. And that's going to be the most accurate way to interpret that. And just some examples of what that looks like. The Army Corps of Engineers requires 0.25 CFM per square foot of envelope area for military buildings, government buildings, federal buildings, anything that standard is going to require. FIAS requires, I believe it's 0.06, I believe. Really tight number, because they're looking at envelope area too, because they realize that ACH 50 just really isn't fair for different size houses. So if you really want to nerd out and get into the weeds in that, Joe Stiebert has from Building Science Club has a good article that he wrote a while back. And to summarize what he said is air leaks through surfaces, not volumes. So it's just a better way of looking at that. But there's some options. If you're not crazy about getting too accurate or into the weeds, you just want a general ballpark idea. You can use ACH, or you can use the floor area square foot method, but and just kind of reference, what some neighboring states are requiring to kind of see if it's in a certain ballpark. And we have some custom home builders that really put a lot on themselves to make it super tight. Even if they're not going for passive house, they want to be under 1 ACH 50 every time. And I'm thinking if you get under 1, chances are that's going to be a really well performing house. You actually take some effort to get there, no matter what size house it is. But that's just some of my feedback from just some different perspectives from different customers that do that.
Yeah, that's great. And I'm glad you mentioned that, because that is a really important question that we do get a lot when there's no pass-fail requirement to compare it to. And
that's when it's a really long-winded answer. It just depends what you're trying to get out of it.
Definitely, and that's perfect. And the comment you made about not wanting to use ACH in a lot of cases, that envelope area is what commercial envelopes typically use. And I believe that's because as the building gets larger, your envelope area doesn't grow as fast as the volume. So, larger buildings are going to have larger amounts of volume, which is going to dilute any leakage you have. Yeah, I'm glad you mentioned that.
Yeah, and with commercial buildings, just the architecture is all over the place. One commercial building can be vastly different than the other, than one next door to it. So you really can't put them on an even playing field. You have to go that route to really get some reliable data. Okay, so the next one is where can I find resources on blower door testing for home builders? This is one that I've seen come across my desk quite a bit here over the last couple of years, because we've seen a lot more custom home builders get into blower door testing, mainly as a quality assurance tool. They want to keep track of the build from the end of that framing stage all the way to final, to make sure that everything is covered along the way. And so there's some good resources out there that kind of cover how to do this. One is the Build Show. If you're not following that already, I recommend doing so if you're a home builder. Matt Reisinger started the Build Show a while back, and it's really gained some popularity. It's really popular on Instagram. They have a great YouTube channel. Great website packed with resources with videos on pretty much anything about home building, and definitely a lot for high performance. And they have some contributing builders across the country that build in different climate zones that deal with all kinds of things that get into air tightness. Jake Bruton is one that I recommend following. He's out of Columbia, Missouri, and he has a method where he does a blower door test at least 3 times throughout the build. So after the air barrier is complete, before windows and doors, after windows and doors, after MEP penetrations are made, and then at final. Just really to keep track of that, because as trades come in and out, if you test in between, which it really doesn't take that much time to do that, then you can really track and see where the problem occurred. So if an HVAC contractor came in, you know what penetrations they made on the outside, if there's been a ventilation or something like that. If your blower door number is higher after they left than before, then you know exactly where to go find that leak. So he's got some great videos on that. Steve Basic is also great. He's an architect that really nerds out on this stuff too. He and Jake do a lot together. Travis Brungart's another one. He's in Kansas City. I believe he just completed a house that had 0.3 ACH50. So they do some really good stuff, and they film everything along the way, show you all the details, how they get there, the materials they use, the processes they use. So definitely recommend following that if you're a home builder. Fine Home Building is another one too. They've been around for a long time. Along with Green Building Advisor, they're kind of under that same umbrella together. Fine Home Building, great magazine. They're really focusing on a lot of high performance aspects too. Ben Bogie, friend of mine, who's a contributing author there, does some great work. And they also have a great Instagram account too that covers some videos on how to do certain details and things like that. As far as testing and air barrier materials. And Green Building Advisor is kind of like their forum. There's some great experts in there that answer questions that pop in. So I've gotten a lot of good answers to questions that I've had over the years from there. And I want to mention Corbett Lunsford too. He's been teaching home performance for a good while now. He's out of Atlanta. He has the Building Performance Workshop, and he also has the Home Diagnosis Show on PBS. He's really good for teaching all types of air tightness testing. He actually teaches live classes at his place in Atlanta, but lots of videos on his YouTube channel. Pretty much anything that has to do with building or HVAC diagnostic testing, he's got a great video on it to kind of go through and how to do that. So if you haven't really kind of looked through his source of materials, I definitely recommend doing so. Okay, so we'll dig into some specifics on some different testing here. So one question that we get sometimes is, can I do a duct leakage to the outside test with only one manometer? So if you're doing a duct leakage to the outside test, you have to have a duct tester and a blower door. And the way you do that is you set them up. I recommend setting both of them up to depressurize to 25 pascals. So essentially what we're doing is with the blower door, we're neutralizing any leakage to the indoors by putting everything under the same pressure. So that way the duct tester is only reading leakage to the outdoors. And ideally you want 2 manometers so you can kind of have full control throughout the whole test, but you can do it with one. You can go ahead and get your blower door running. You can manually set your dial on the fan to go to 25 pascals and just read that pressure. The flow doesn't matter here. We're just trying to get it to 25 or negative 25 pascals. And then you can pop the manometer off with the fan still running, set that manometer up to do a duct test, and then run that with the blower door fan still running. So you can do it. It's not ideal, but it is possible. And we get a similar question about this with zonal pressure diagnostics. This is when you usually use a separate manometer with the blower door running to negative 50 pascals to investigate different parts of the house to see if it's going to be leakier than it should be. So this is used a lot for enclosed crawl spaces, basements, and encapsulated attics. So in this scenario that you see here, this is a encapsulated attic where someone is running a blower door test down to negative 50 and then using a separate DM32 to reference that attic space. And here, if we're only getting about 4 pascals out of 50, then it's a pretty good attic there. That's sealed up pretty well. The closer that number is going to get to 50, the leakier that it's going to be. But again, you can manually set your blower door to go to 50. And by doing that, you have to unplug the data cable from either the gauge or the fan. You can't have that Cat5 cable connected to the fan from the gauge. Once you disconnect that, it frees up that manual dial on the fan. So then you can just turn it once you get to 50, and then disconnect your manometer with the fan still running, then set it up to read pressure for zonal pressure diagnostics. So once again, not really ideal, but you can do it. This might be a challenge, maybe if you have people coming in and out of the building, if someone opens a window or a door or walks in, since it's not connected to the gauge, you're not going to hear that fan ramp up or something like that. So it could throw off some readings that way. But if you have full control of the house, and you know no one's coming in or out, or nothing's going to change in the envelope while the fan's running, it'll work. But I think it's always better to have a second gauge. But again, you can do it with one.
Yeah, and Sam, if I can just add that,
Sure.
so for the ZPD, it doesn't really apply as much, but for the duct to outside, you dial in the blower door fan with the manual speed knob if you're doing it with one gauge, and then you go to your duct tester and you start that to read your leakage to the outside. The act of starting the duct tester and neutralizing the leakage from that duct system, if there's a significant amount, it'll actually change the pressure in the house because the fan's just running one constant speed. So if you're doing that single gauge method, you typically want to go back and check the house pressure after you've started the duct tester. So run both with a manual knob usually. But it is definitely more legwork, and you want to be sure that what you're expecting to happen is actually happening, that the pressure in the house matches your target, as well as the pressure in the duct system.
That's a great point, Lee. I definitely forgot to leave that out. So yeah, after you get your reading with the duct tester, go back to the blower door or some way to measure pressure back to the outdoors, and see if you still are at that 25 to make sure that that duct tester didn't change it. Because yeah, that's why when we do a total duct leakage test that require a window or door to be open to neutralize any pressure that might happen from that duct leakage. So yeah, great point. Yeah, it becomes kind of a balancing act. When you have that happen, you'll have to maybe ramp up or decrease the fan, just depending on what happens. Okay, so for a lot of folks that start out with blower door testing, yeah, it's great when you get the measurement, but how do I find where the problems are? And so with the blower door, there's other tools that you can use that really make this a lot easier if you have access to them. Thermal cameras always going to be one of my favorites. Just having a way where you can actually see it. One thing that makes air tightness testing and finding air leaks so hard is that air is invisible. You can't see it with the naked eye. So any tools that we can use to make it visible is great. So here, I'm in an attic, and we are pressurizing the house with the blower door down below. And this is in the winter. And so we can see warm air from the conditioned space down below getting pushed into the attic here with a thermal camera. So we were able to really find some major leaks in this attic when we were here that day pretty quickly with a thermal camera. If I am, so in this case, I'm outside of the building envelope, but if I'm inside of the building envelope, I like to have the fan depressurized so it's cooling that air in. So if it's a cold day, then I can see that those darker colors start to exaggerate more and more when I'm on the inside. And sometimes I like to do this before I run the blower door test. When we run a blower door test, if we're just doing a single point test, we get the building up to or down to negative 50 pascals. But sometimes I can exaggerate some leaks too much, especially if you're doing like passive house or really trying to find leaks in a tighter enclosure. You don't want to exaggerate them too much. You want to be able to pinpoint and see where they are. So if you started at a lower pressure, like 15, 20 pascals, and then walk around and look, you can see a lot more detail usually. And the key here for thermal imaging is having enough delta T or temperature difference between inside and outside. So the common recommendation that we see is 14 degrees. You want at least that much difference between inside and outside. I've done 10 degrees before and be able to see what I need to see, but usually if you're under that, then you're just not going to see a whole lot with the camera. So having that temperature difference is what really makes it handy. But if you're testing in the spring or fall, a lot of cases you don't have that. So then you'll need to use something else. And so smoke testing is just another way to make these air currents visible to see where leaks are happening. So this is a bottom plate on an exterior wall. You can see the baseboard and the floor meets, and we're pressurizing the house again here. We can see that that fog quickly escaped outside. So here we can see these bottom plates just were sealed. And another way that I like to use this small smoker here is by pressurizing the house. And then if I have bedrooms on exterior walls, which I usually do, I like to shut the bedroom door and then discharge the fog at the undercut. And if I see that fog get pushed up under that undercut, then I know I've got some leaks to the outside there somewhere that are pretty significant. So lots of great ways that you can use this to make that air current visible that leads you to where some of the problems are happening. And you can do it with a larger smoke machine too. We actually carry one that you can fill an attic with or a room with. So we have testers that will fill an encapsulated spray foamed attic with foam, pressurize it with the attic door open so that the attic gets to pressure as well, and then walk around outside and see where it's coming out. And it's almost always at the soffit where they just didn't seal well there, where they couldn't get to it. So if you are going to go that route, it's going to look like the house is on fire from the outside. So just let the fire department know you're doing that, or the neighbors will call. And sometimes that can end up with a fine. So that's happened before. So just keep that in mind if you go the big smoke route. But we also see folks doing that at the rough end stage of construction. If you get your air barrier finished still at the framing stage for a new build, you can pressurize it, discharge a lot of smoke, and then have somebody walk around outside and just kind of really see what details got missed there. And then, of course, too, just probing around. With that 50 Pascal pressure differential between inside and outside, if we're doing a depressurization test with the blower door, if we're getting it down to negative 50 Pascals, then there's a positive pressure right on the outside of the building as that air is coming in. So here, if we're testing floors, ceilings, or exterior walls with a tiny probe where we can get in to little nooks and crannies, we can find spots that are happening. So in this case, this is a elevated slab foundation that meets a crawl space that didn't get sealed at that joint. So there's air coming in up from the bottom. But we're able to get this tiny probe in there underneath the true molding to see that. So we didn't have to drill any holes or anything. So just looking for pressure differentials can tell you a lot too. So those are my three favorite ways to do it. This one might be one of the, probably the most common question that we get is how large of a building can I test with one blower door fan? That's another one of those it depends answers. If I go back to, if you have the DM32X manometer, the one we came out with this year, if I have the gauge app open here and I click on this picture of the fan, it goes to the different ranges that I can go to. And so we can see that the maximum flow for this fan, which is a model 5000, that's free air. So about 6,200 CFM. If you put a 50 Pascal back pressure on it, it'll be a little less, just slightly under 6,000 CFM. So that's one thing you need to kind of have some expectations. Like, what are you looking for? What target are you looking for? Is it 5 air changes per hour? Is it 7? And if it's a large house, then you're going to need to move more air. So if we're getting upwards of 5,000 CFM, I mean, that amount of airflow coming out of a blower door fan will cover most houses out there. But if we're getting into some big mansions or something like that, sometimes a second fan is needed, especially if it's very leaky. So it's good to know how much airflow will get you in certain spots. So, for example, if you're looking at like a 2,000 square foot house, I would hope that at least 5,000 CFM of flow would definitely cover you there. But most of the time, one model 5000 will cover you. But usually, when 2 fans are needed, it's going to be in a really large, expensive house, or it's going to be in a historic home that was built, over 100 years ago. That's usually where I see 2 fans needed. But if we're talking about new construction, I would hope that one fan would cover you there. The only time I've ever needed two fans for new construction in the past few years was for a house that was 26,000 conditioned square feet of floor area. So it was massive. So I needed two fans for that one. But most cases, though, if there's some effort being made to have a somewhat decent air barrier, one fan should cover you for new construction. But it's big existing homes, older ones, that you're usually going to kind of cross that barrier there. Sorry, go ahead, Lee.
I was just going to say, if you know your pass fail limit, like your air change rate limit, then it's somewhat easy to calculate if you'll have enough fan power to hit that. So you can take your house volume. Oh, the calculator's here too. House volume times your air change rate, divide it by 60, and that'll give you the CFM that you need for that house. But Sam, go ahead.
Yeah, perfect. Yeah, I was just going to mention this too. This is a number of fans calculator. Most people who use this are commercial building testers, but sometimes it's needed for residential too if we're talking about very large structures. So you can input specific parts about the building, such as the total height, number of floors, or if you have the envelope area, you can input that as well. And then we have some different standards that are posted in here. Such as Army Corps of Engineers or LEED or ATMA in the UK or Passive House. And then you can also put your own, custom standard in there or code that you're looking at, and it'll tell you how many fans that you would likely need, of which type of fan, whether it's our standard 5,000 or high-powered 6,000 fan, to give you a pretty close estimate of how much fan power it's going to require. So this is free to download. You can download this from our website under tester tools. So yeah, how do I figure out how many fans I need? We just covered that. So yeah, any building can be tested as long as you have enough fans and time and people to run it. So
do you want to show them really quickly where it's at on our website on that tab?
Sure. Yeah, we can do that. And it's going to be under software, tester tools, number of fans calculator. So yeah, just download it. It's just an Excel sheet that we put together just for this reason.
And there is one for blower door and then one for integrity. There's two separate tools for that. But
great. Yeah, thanks, Tim. So yeah, if we have any fire testers on today, got you covered there too. Yeah, number of fans calculator for integrity. There it is. But yeah, there's lots of other stuff in here too. I'm not going to really get too much into it, but a stack effect calculator that we put together, results at different pressures, unit conversion, the DM32 flow calculator. This is handy too, just to kind of see what fans, fan ranges, what different flows that they can do at different pressures. So if you need some answers to that, you can pull it up there. So some handy tools that are in here. So if you need more than one fan, how do you get them to cooperate and work together? We have two different ways of doing that. I'm actually going to stop sharing here quick. And then I'm going to change my camera. So what you see here are the drives for our Model 6000 fans. That's one noticeable difference between the 6000 and 5000 is that the 6000 requires one of these external drives just to give it some more power, more airflow. But on all of our fans, whether it's the 6000 on the drive, or if it's on the 5000 or the duct tester in the Model 5000 have a similar plate, but you'll see that there's an in and an out port for the data cables there. So on the drives, we have an in and an out. And so that's what we use when we want to do a test. It's going to require what we call common control, or daisy chaining the gauges together, or the fans together. And so you'll have a primary fan. So in this case, this is our first one on the line. And so it's getting a signal in from a manometer here in this in port. And then all we're doing is taking another data cable, Cat5 cable, and connecting from this gauge and the out port going in to the next drive. So all of the drives are getting the same command from the same gauge. So they run at the same rate at the same time. This is good for if you're testing one large volume of space that's not separated by party wall or something like that, or common wall. Yeah, if anytime you hear daisy chain or common control, that's where we're going to do that physically. Now, let's just say you're an HVAC contractor doing a comfort console and you just need the extra boost of power. Do you always need software? Not if you just have two fans and it's pretty easy to do. What you would do is the second gauge that would be connected to this fan, you would not have a data cable coming from that gauge to the fan. The only thing that's connected is the tubing. And so when you have that first gauge, when you input 50 pascals set and you get your reading, you take the CFM on channel B on gauge 1 and gauge 2 and just add them together. That's your CFM. But if you want to generate a report, do some multi-point testing, then software is where you want to use to generate your reading there by hooking up the fan testing. The other way that we would have things set up is independent control. So that's if you're doing like a guarded test or a neutralization test on maybe duplex or apartment buildings. So instead of daisy chaining the fans together, that's when you would have each separate manometer connected to the fan. And then in the software, you would want to make sure that you have that selected. So there's the option of common control and individual control. The common control is in one gauge, is telling them all what to do. Individual control is where they're all separated out. So if you have two apartments, it might take a different amount of fan power to get each one up to 50 pascals. So that's kind of the quick and dirty on how to do that. But if you're just trying to do a rough check, just to add up that CFM, you can do that. And the main reason why that we want to daisy chain them in that scenario for testing a large volume of space is that if we don't, we can get the fans fighting each other, and it may not generate some reliable readings. So that's really the important thing there to take into account.
Hey, Sam.
Yes.
I'm going to share screen again really quick.
Okay.
If I can, and then I'll show them where to set that. Can you see me there?
Yeah.
Up in the top again in settings and then advanced. This is within Fantastic. If you click on that, whoop, I have to move this screen over now. Can you see that setting, that pop-up window? I'm not sure what the screen sharing. Okay. So right under here, gauge control, common or individual to set for Fantastic for what you were talking about there.
Yeah, so that's a really important window to be familiar with if you use Fantastic. It says advanced, but it's not. It's very much needed in pretty much every test you're going to do to set things up.
So just to add to that real quick, the setup that Sam was just showing with the cabling would be hardware daisy chaining, where you're physically connecting the drives together. So you have one gauge, control both fans. This setup window is software daisy chaining or software control. So this is saying that the software is going to try to send either the same speed control signal to all gauges, or it'll tell each gauge to get the pressure individually. So they accomplish largely the same thing, but they are two different ways to do that. And in some cases, you have to mix them, but I think that's a little bit beyond what we can cover here on this webinar. If you're doing software control with multiple fans and different zones, reach out to us and we have some diagrams we can send you and can give you some tips on that.
Mm-hmm.
Yeah, thanks for that, guys. I think we're at a good point here to take some questions. Noah has been monitoring the Q&A and chat box. So Noah, I'm going to kick it over to you to see if we've had any that popped up.
Yeah, there's some good ones here. So I'm going to start with, there's two that are about measurements of houses that don't have plans. So either calculating your envelope area or your volume when a house doesn't have plans. And unfortunately, there isn't like some super easy way to do it. You are going to have to do a lot of measurement out in the field and probably bring a piece of graph paper with you if you want to keep things straight. But for envelope area, the kind of cheat that I like to use is measuring the perimeter of the house and then multiplying that perimeter by the height of the walls. And then you'll get the surface area of all your walls. And then you can take your square footage and kind of double it to get the square footage and the ceiling area. If it's a fairly simple envelope, that doesn't work for like vaulted ceilings and some other situations like that. But hopefully that helps a little bit. Same with the volume of the house. I like to get square footage and then multiply by the height of my ceilings to get volume. But generally, I think a laser tape measure is your best friend. It makes this go a lot faster than using a traditional tape. But yeah, a lot of measurements going to be involved in that no matter what you do, unfortunately. And then another one, most of these pertain to duct testing now. So what has to be done differently when a duct tester has two air handlers on two different stories? So you'll basically treat each air handler as its own duct test. So you'll basically be doing the whole thing twice on each system. That's what's done differently there.
Yeah, so it's important to know the square footage. If you're trying to report that and a percent that the square footage serves, like if you're trying to get 4 or 5 or 6% duct leakage, if you have to report it that way, then you have to know what the square footage of that house is that system serves to be able to report that. So it's good to go ahead and have that planned out beforehand.
Mm-hmm. And then the next one is there a duct cover or register cover with a built-in duct attachment? We do for our residential tester. Here, I'll share my screen and pull up. One sec. We have our clear flange here that you can see. So this, these little knobs, they have a hook on the end of them, a J hook. So you can push it in and it kind of grabs onto the register that you're connecting this to. And it holds it while you tape it into place because this isn't going to cover an entire register most of the time. So you'll still need to tape this into place and seal it. But this is our option for a residential. There is a similar flange for our commercial duct tester. And that's kind of our best option for connecting to registers. If you're connecting to the air handler unit, unfortunately, we don't have one specific to that. You can use this still. Because those air handlers come in such a variety of sizes, there's not really a good option for an adapter to that.
Yeah, most people just make one out of like corrugated plastic or foam board.
Right.
And then just tape to it. If you're not familiar, there's a company out there called Vent Cap Systems that makes something similar for supply vents that is a reusable cap with a gasket. Yeah, you can seal supplies, and from what I've heard, that they're working on one for returns too. But I would think that piece of plastic would have to be pretty big to cover a lot of the different main returns that are out there. But if you're not familiar with them, you can check them out or ask where they are with that. But otherwise, yeah, this clear flange has been working great for us because it attaches to most of the builder grade returns that are out there, especially if it's on the ceiling. It's great because then you don't have to hold it with one hand and take with another.
Yep. And then another one of the questions that we get commonly is that the system on the manometer does not match the model number that they have. So say you have a 5100 blower door, but the manometer says that it's a 5000 system. That's a pretty common question. So the best way I know how to explain this is just to show you on this blower door page. So the 5000 is the series number. And then the numbers after that are just different options within the 5000 series. So the 5100 is our common residential system. But then if I scroll down here, you can see a 5120 is a hard panel, but it's still the same fan. And that's the important thing that the manometer needs to know is it needs to know what fan openings there are and what fan motor it is. So as long as you've selected the right series, so if you have a commercial duct tester, it's that 450, whether you have the package that's a 440 or 450, if that makes sense.
Yeah, it's that first number that matters. So the commercial duct tester is always going to be a model 400. A residential duct tester is always going to be a model 300 fan or 340. That is one thing that's a little bit confusing, which is why we broke up. Here, I'm going to take over right quick, Noah.
Awesome.
And show you the screen of this DM32X again. If I go back to change device, we try to put them together so that the duct testers are all together and then the blower doors are all together, because a model 300, well, no, they are all together here. The model 300 is when this duct tester fan is used as a blower door. So if you saw that screen that Noah shared, if you see the model 300, it's usually this is used with passive house. The model 340 is when it's used as a duct tester. So that's the one thing that I see a lot of the confusion on. But yeah, just pay attention to that first number and what kit you have. So if you have a model 5000 blower door fan and a model 340, then yeah, 340 is what you'll always choose for duct testing. You'll likely never use that fan for blower door unless you have the small hole cloth for it.
Mm-hmm.
So yeah, great question there. That comes in quite a bit.
All right. And one more about